Hello folks, and welcome to section 6.2. We are going to be spending 3 days on this section. In this section we will be talking about 3 different topics, all of which will be using properties of roots and exponents. So you need the graphic organizer I gave you in class, something to write with, and a calculator. If you don't have a graphic organizer, just go ahead and write them directly into your notebook. Okay, so your graphic organizer is going to look like this. We are going to write using properties of roots and exponents and how to simplify the expression on the very top part of the graphic organizer. And then the 3 tabs below that will each have its own little topic. The first topic is simplifying exponents. This is what we are going to be doing today. Simplifying radicals, that's the second day, and radical operations will be day 3. So this will be day 1, this will be day 2, and this will be day 3. All right. So before we go ahead and begin, I want to review the properties of exponents. Now, I know we spent Monday, Tuesday, and Wednesday on these, and so I need to make sure that we understand these properties before I go ahead and change these into fractions. So if I have 2 bases that are the same and I have a multiplication sign between them, it means I can add the exponents. So this would be x to the 8th. So x to the 3rd times x to the 5th would be x to the 8th. If I have a power to a power, then what I can do with these 2 is multiply them. So if the one base is to a power and then it's to another power, we multiply. So this would be x to the 15. If I have 2 different bases, but they're both to the power of 5, I look at each power. If they don't have a power, I give them a 1, and then each one of them gets the power of 5. So a to the 5th times b to the 5th, because 1 times 5 is 5, 1 times 5 is 5. If I have the same base and they're being divided, then what I can do is I can take and subtract their exponents. So a 4 minus 2, which is equal to a to the 2nd. If I have a division, but they're not the same base, they're different bases, okay? So we have 2 different bases here, but they're both to an outside power. Then I can say that each base is to the power of 1, because I don't see a power on either one of them. And I can take 3 times 1, and I get 3. And I can take 3 times 1, or 1 times 3, and get 3 again. So everything inside, numerator, denominator, gets the outside power. The 6th one is a negative, and we can't have negatives, so we have to decide where the fraction sign is, or the division sign. Here's the division sign. So in order for this to become a positive, I have to cross the line and change the sign. Cross the division sign and change the sign. So it should be 1 over a to the positive 3. Okay, so those are the review of the properties when we have integer values. Now we're going to go ahead and talk about simplifying powers, okay, our exponents, but now we're going to simplify those exponents when they are fractions, okay? So here we go. How do I use the rules of exponents? We need 6 parts to our graphic organizer once you flip open the first flap. This is going to be the inside of the first flap. We're going to divide those 2 sections into 6 parts because we have 6 examples. All right, example 1 is 2 to the 3/2 power times 2 to the 5/4 power. If your bases are the same, you can add your exponents. Okay, so we're going to add our exponents. So 3/2 plus 5/4. Do that in your calculator. If I don't have a calculator, which I don't have right now, I need lowest common denominator. I need the lowest common denominator. I need both denominators. Okay, so the lowest common denominator would be 4. So in order for this fraction to get a 4, I would multiply the top and the bottom by 2, and I'd get 6/4 plus 5/4, which would be 11/4. So the answer would be 2 to the power of 11/4. Okay, and that's as simple as I can get. Example number 2 is I have a power that's to another power, and those two powers can be multiplied. So I'm going to multiply exponents here. When I multiply numbers that are fractions, I multiply across the top and across the bottom. So numerator times numerator, that would be 6. Denominator times denominator, that would be 24. And then I simplify 6/24, which would be 1/4. So the answer to this problem would be 4 to the 1/4 power. Okay, now let's go on to examples 3 and 4. So here's number 3. I have two bases. Each of them have a power, and they're both to the power of 3. So if you remember the rule on this one, every base that has a power gets the outside power. So I'm going to give everybody the outside power. So 1/3 times 3/1 is 3/3, which is 1. So this would be 5 to the 1 power times, now the 7 and the 5 are not the same, so I can't put them together or anything like that. I look at the 1/4 and I multiply it by 3, and 1/4 times 3/1 would be 3/4. So then this would be times 7 to the 3/4. Okay, and what I'm doing is giving the power to all. Now I have two bases that are the same, and when I have two bases that are same that are being divided, I can subtract their powers. So I'm going to take 9/7 minus 1/2. Now you can plug that into your calculator. If you don't have a calculator, you have to have lowest common denominator. Lowest common denominator is 14. I'd have to multiply this fraction by the top and the bottom by 2 to get 14. That's 18/14. To get 14 in the second fraction, I'm going to multiply both the top and the bottom by 7. And now I'm going to, if I have the same denominator, I can subtract the numerators. 18 minus 7 is 11/14. So this would be 8 to the 11/14 power. Okay, we have two more examples. We have a division problem with two different bases, and the rule is you give the power to the entire fraction, both the numerator and the denominator. So we first have to decide what is the power or exponent on this x. It is a 1. Remember, if you don't see it, it's a 1. And if I give it to the 1/3 to the entire fraction, I'm going to multiply those. So 1 times 1/3 is 1/3. And then I'm going to also give that 1/3 power to 27. So 1 times 1/3 would be 27 to the 1/3 power. Now, if you have that yellow sheet out, we should know that the 27 to the 1/3 power is the cube root of 27, and the cube root of 27 is 3. So I just added a little simplification in there from the yellow chart that you have in front of you. Okay, I have a negative exponent. What do I do when I have negative exponents? I have to move the base with the negative power across the division sign and change the sign. So this is going to become 4 and 7 halves times 4 to the 3 halves. And because they're on the same level, I can now add their exponents. So I'm actually doing two things here. Because the bases are the same, I can now put them together by saying 7 halves plus 3 halves is 10 halves. 10 halves is 5, so the answer is 4 to the 5th power. And you could simplify this if you wanted to, but I don't have a calculator in front of me, so I'll just leave it 4 to the 5th power. Okay, a couple more examples. You can follow through or put them in the bottom of your notes. You're just going to be looking for, what do I do? I have a division sign. I have two of the same bases. What can I do to the exponents? I can subtract them. So 7 halves minus 3 halves would be 4 halves. 4 divided by 2 would be 2. This would be 4 to the 2, which would be 16. A little bit different because I don't have a negative here. Okay. This says 3 over 3 to the 1/4. Now right away you're going to think, oh, these aren't the same. I can't do anything. But this is a base of 3. This is a base of 3. The power or the exponent on this 3 is a 1. And if the bases are the same and I have a division sign, I can subtract these. So 1 minus 1/4, that'd be 4/4 minus 1/4, which would be 3/4. So this would be 3 to the 3/4 power. Okay, that's all I have. Hopefully you understand how to use exponents, and we'll come back and work on them tomorrow. Thanks.